Hello students, previously we have learned about tides and their types, spring tide and neap tide. Tides are movements of seawater occurring daily and regularly. The tides are regularly occurring natural phenomena. Today we are going to learn about a natural resource that is very important for our life and of course for all living and non-living things. For breathing, we have need air. Yes, we are going to discuss about air. It is vital that living things respire to get oxygen for living cells to function. Without air, there is no life. What is air? Air is a mixture of nitrogen, oxygen, and minute amounts of other gases that surrounds the earth and forms its atmosphere. Students, if anyone asks you where is air, maybe your answer would be air is in earth's atmosphere. It is okay, but can we see air? As we know that air is in a gaseous state and colorless. We cannot see the air, but we can feel the air when it blows. Students, as you know that anything that has white, air also has white. Maybe you have tried the activity regarding the air has white, which is given in your science textbook, page number 16. Let us revise this activity before going to get further information about air. Let us see. And now, let us try this activity related to air has white. Take a stick from broom or a paper or a plastic straw. Here, we are going to use white plastic pipe. Look at this pipe. It is a white plastic pipe, mainly used for water supply. Tie a thread at its center and hang it so that it remains horizontal. Here I have used a rope for hanging this pipe. Look at this. I have tied a rope at the pipe's center and hanged it so that it remains horizontal. Look at this horizontal situation of white plastic pipe. And now tie two rubber balloons of the same size at the two ends of the pipe. Look at these two balloons. These two balloons have same size, and now I am going to tie these balloons at the two ends of pipe. Look at this first balloon. I am tying this balloon at the first end of pipe. I have tied first balloon at the first end of pipe. Now I will tie second balloon at second end of plastic pipe. Look at this. I have tied two rubber balloons using thread at two ends of plastic pipe. See to it that the pipe remains horizontal. After tying these two rubber balloons at the two ends of pipe remains horizontal. And now remove one balloon. I have removed one balloon and now inflate this balloon using air pump. I am going to fill air in this balloon. Look at this process of inflate balloon. After filling air inside the balloon, it becomes inflate. Look at this inflated balloon. I have filled air inside the balloon using air pump. And now tie this balloon again at its original position. This inflated balloon I am going to tie again at its original position. After tying inflated balloon at the original position, at the one side of a pipe, this pipe does not remain horizontal. Look at this. The pipe goes down on the side of the inflated balloon. This means that air has weight. Air is a mixture of gases. Therefore, like all other matter, it has a mass and weight. During the activity, you saw that the balance tipped on the side of the full-blown balloon. This shows that the air has weight. This is a simple demonstration. But why does a balloon filled with air fall one side when it is only surrounded by air? Why does not it just remains where it is? When you blow off the balloon, you are increasing its overall density by forcing air inside it. That is because the air inside the balloon is under greater pressure than the air outside. It is being squeezed tightly by sides of the balloon. Greater pressure means greater density, so the heavy air inside the balloon will fall. What is the density? The relation of the weight of a substance to its size are an important property of any gas, including air, is a density. You know that air is a mixture of gases like nitrogen, oxygen, water vapor, carbon dioxide, and various other components. Due to this air pressure, various phenomena like storms, precipitation in the form of rain, sleet, hail, snow, cyclones, etc. occur in the atmosphere. There are variations in the air pressure. Air pressure is not uniform on all places on the Earth's surface. Air pressure keeps on changing from time to time. The altitude of a region from sea level, temperature of the air, amount of water vapor in the air are some factors influencing air pressure. Anything that has a weight exerts pressure on the thing that lies below it. Thus, the air in the atmosphere exerts pressure on the surface of the earth. Gravity pulls the air molecules towards the earth, giving them weight. What are molecules? Molecules are neutral particles
made up of two or more atoms bonded together. And what are atoms? Atoms are single neutral particles. The universe is made up of atoms. The weight of the air molecules, see these air molecules, the weight of the air molecules pulling down and all around us is called the air pressure. Air pressure at sea level is 14.7 pounds per square inch approximately. First, we will see that how altitude of a region influences air pressure. See the graph. The pressure of the air can be related to the weight of the air over a given location. Weight of air is known as air pressure. Air is a composition of various gases, therefore it has a specific weight. We have learned it. Mercury barometer device is used for measuring air pressure. Air pressure at sea level is 1013.25 millibars or 14.7 pounds per square inch. At sea level, there is more air, but as we move up or increase altitude through the atmosphere, there will be some air below us and some air above us. But there will be less air above us than was present at a lower altitude. This means that as we move up or increase altitude through the atmosphere, air pressure decreases. At a higher altitudes have a lower pressure, and at lower altitudes have a higher pressure. The proportion of dust in the air, water vapor, heavy gases like nitrogen, oxygen, argon, carbon dioxide, etc. is higher in the air closer to the surface of the earth. This proportion decreases with increasing altitude. As one moves higher and higher from the surface of the earth, the air becomes thinner and thinner. As a result, the air pressure decreases with increasing altitude. It is because of low pressure in mountainous regions that breathing gets hard. Air pressure is measured in units of millibars. For this, an instrument called barometer is used. The air pressure at the Earth's surface is measured with this instrument. The air pressure at Earth's surface is 1013.25 millibars or 14.7 pounds per square inch. And now we will see next factor that influencing on air pressure: temperature. Temperature and air pressure are closely related. Wherever the temperature is high, the air pressure is low. As the temperature rises, the air gets heated, expands, and becomes lighter. This lighter air in the vicinity of the Earth's surface starts moving up towards the sky. As a result, the air pressure in such areas decreases. Air density plays a role in the correlation between temperature and air pressure because due to more heat, air in the atmosphere near the Earth's surface becomes warm, and warmer air influencing density of air, it becomes less dense than the surrounding air and creates low air pressure in the atmosphere of a specific area near the surface of the Earth. Warm air molecules have more energy, so they move more faster and bump into each other more. Due to this movement, they expand and becomes less dense. They take up more space for bumping with each other with great velocity. These charged molecules moves up for getting space. Because in the surrounding of these molecules is more density and high air pressure, they moves up in the space. We have learned that as we move up in the space, temperature of air decreases in the cool temperature, density of air and air pressure decreases. As these molecules rise up in the space, due to less heat, they lose energy. Due to less energy, they move more slowly. Their movement's velocity decreases. As a result, air contracts and its density increases, and air pressure also increases. As these molecules rise up in the space, due to less heat, they lose energy. Due to less energy, they move more slowly. Their movement's velocity decreases. As a result, air contracts and its density increases. And air pressure also increases than the surrounding air. Due to this situation, group of these molecules sinks again in that region. This process of warm air and cool air is called convection in air. Convection drives the circulation of air in the atmosphere.